Hey guys, welcome back again for another day of online math learning. I'm excited for today. We kind of get to move in and transition to a new unit. We're going to look at a new topic, topic 11. It's going to deal with what we call congruence and similarity. Okay, so we'll look at a lot of that. I hope you guys enjoyed your weekend. That you're still staying safe and healthy, and everyone in your family is doing well. I just want to let you guys know I do miss you. I do miss being in the classroom with you guys and having the conversations that we share together. It's part of something that I am missing. Please make sure you check the Math Olympic standings. They are updated as of, it should be Monday morning. So make sure you guys have taken an opportunity to look at that. So in my hours of free time that I've had of just being stuck in the house, I've had a lot of opportunities to kind of reminisce and recall some of my youth or past. And one of the things I got stuck on was 15 years ago, I was in 6th grade, and I couldn't imagine kind of going through, going through what you guys are going through back then. We didn't have Netflix, we didn't have Hulu, we didn't have a lot of the streaming services or capabilities that you guys have today. So I got thinking, like, how would I have kind of gotten through that and everything? And that kind of got me thinking back to some other memories that I have from 6th grade. So to kind of add a little bit of fun to these videos, I figured I would throw in maybe some trivia from time to time at the beginning about my 6th grade self, and then I kind of want to compare it to your guys' 6th grade self now, see if there's any similarities or see if how different things are now. So, just a little fun. If you get this question that I'm going to post here on Edpuzzle, it's not going to affect your grade in any way. It's just kind of fun. So, kind of give it your best shot with it. So, your trivia question about my 6th grade self today is what was my favorite TV show in 6th grade? So you got to remember, when I was in 6th grade, it was 2004, 2005. So about 15 years ago, and we'll focus on the 2005. What was my favorite TV show at that time? I'll give you a little hint, because we didn't have Netflix or any Hulu or any other streaming services. It was on a channel called Nickelodeon. So see if you guys can figure out, and then I want you guys to also tell me what is your current favorite TV show as a 6th grader. If you don't watch TV, just anything else that you may watch on YouTube or something else. So go ahead and give me that now. Alright guys, we're going to jump in to our topic today, which is 11.1, and that is translations. I will dive more into what translation means, but I want to look at this example that we have. So a landscape architect shows that a plan for a new patio to a client. The client wants the fire pit moved 6 feet to the right and 3 feet farther from the house. Where should the architect place the fire pit, and how will the client's request change the fire pit? So here's our fire pit down here. Now the client wants to move that fire pit 6 feet to the right and 3 feet further from the house. So this type of movement we actually call a transformation. You can kind of see it highlighted here, and I'll do my best to circle it. But a transformation is taking a figure or an object and changing its position, its size, or the shape of it. So think of the word transform is to make different. So in this case, the transformation is just moving that object either to a different location, changing the shape of it, or the figure or the size of it. Okay. The specific kind of transformations that we're going to look at is mainly on position right now. Okay, so we're not changing the structure of the shape, but just the positions of it. The first one we're going to look at is called a translation. And the translation is a transformation that moves every single point of the figure the same distance in the same direction. Okay? Actually, the word translation, so if you look at the word trans right here, okay, trans means across, okay, or to move across. And so that's really what you're doing here, is you're going to move across figures to get a different figure. Okay, you're going to do that on a coordinate plane, but we're going to look at this example first. So here's the fire pit. It's moving 6 feet to the right, okay, and 3 feet down. Now notice how the fire pit in this translation, we're not changing anything about it. It's the exact same fire pit, same dimensions and everything. It's just being moved. Okay? A great way to think about this is if you were going to rearrange your room right now, your bed, maybe if you have a bookcase or a desk, something of that nature, but let's focus on the bed. Okay, if you were going to move that somewhere in your room, you know, from one wall to another, or just out a little bit from the wall, wherever it may be, okay, maybe in the middle of your room, I don't know. But the composition, meaning the size and the shape of the bed, it's not changing. Okay, most likely it's probably in the shape of a rectangle. It's not going to change shape to like a trapezoid or a different quadrilateral. It's going to stay the same shape. You're just translating it or moving it across your room. And that's what's happening here in this fire pit. Okay, I highlight this point here just to emphasize that this point is being moved 6 feet across and 3 feet down, and that's where it's the same point, just in a different location. And you could do that with all 4 points here. Let's kind of look at some examples with translation. So we have polygon ABCD has vertices of A, -1, 6, B, right here, 4, 5, C is 2, 2, and D is -2, 0. We want a graph, so we already have our graph of quadrilateral ABCD, and label these vertices, and we want to graph and label what we call A prime, B prime, C prime, D prime, its image after the translation of 8 units down and 3 units to the left. So if we were to do this, we'd have to take every single point and move it the exact same distance from that point. So let's take a look at A. So we're going to go 8 units down and 3 units left. Now the order of which one you do does not matter. You could go 3 units left, 8 units down, or 8 units down, 3 units left. Okay, I'll go ahead so you guys can maybe see it a little better. I'll move to the left 3 first. So we're here, we go 1, 2, 3. Now we're going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And this is where our new point is, and we actually call this A prime. Okay? You put a little apostrophe next to it, and that turns into what we call A prime. The number's not prime. Okay? It's a different terminology for the word prime. So we have the original A. We can't call this A because A is already -1, 6. So this is a different point, but it's part of the same, it's the image of the figure. So we just call it A prime. Do the same thing with B. So 1, 2, 3, all the way here, and we're going to go down 8, right here. And this is what we would call B prime. That's a much better B than last time. All right, then we're going to move C over 3. We're going to go down 8 again. This is our C prime. Do the same thing, D over 3 and down 8. And we have D prime. You can then go ahead and connect these points. And while my lines aren't straight, it is going to make the same figure, but just a translation of it in a different location. So as I mentioned before, we called these prime. So this image, okay, is now A prime, B prime, C prime, D prime, which is indicated up here. Okay. we call this an image, and this is a figure. So the figure is kind of the pre-existing image. And then when we make a transformation, we call that or even in this case, the translation, we call that the image. Okay? A little bit more information here. So as I mentioned, in the transformation, the original figure is the pre-image. We would call this figure ABCD. And then the image is the resulting figure. This would be image A prime, B prime, C prime, D prime. And as I said before, the image of point A is point A prime, read as A prime. Okay? The great part about translations, since we're just moving its location, as I said before, everything else stays the same. So the corresponding side lengths are going to be congruent or equal. So AB, which is up here, is going to be congruent to side A prime, B prime. BC here is congruent to B prime, C prime. Side length CD is congruent to side length C prime, D prime. And then side length AD is congruent to side length A prime, D prime. And this is also true for angles. So measurement angle A, the measurement of angle A here, is congruent to the measurement of angle A prime. And the same with B, angle B and angle B prime. I need to change that, put 2 arcs there. And then C, which would need 3 because they're not the same. And so on with D. Okay, the angles are not going to change either. Okay. So one other little aspect I want to mention here is how we would write this rule or describe this type of translation. So what's happening to every single x coordinate and every single y coordinate? Okay. Well, we said that our rule is we're moving down 8 and then to the left 3. Let's take a look at a closer look at this. So how we would write this is what's happening to the x every single time, or what are we adding to the x? Well, if you look at our x coordinates, this is our x-axis. Okay, we're moving to the left 3 every single time. Okay. But we can't just say we're adding 3, because how do we know if we're going right or left? So in this case, we're going to use positive and negative. Anytime we move to the right, it's positive. Anytime we move to the left, it is negative. So x plus, and we're moving to the left 3. So every time to the x, we are adding negative 3. What about the y? Well, in this case, we're still adding. We're moving down 8. The y-axis is a little bit easier to work with because moving up is positive, moving down is negative. So with y, you're adding a negative 8. Okay. Let's take a look at one more example here. I want you guys on your own right now to go ahead and try to write a rule that's going to describe this translation that maps trapezoid PQRS onto trapezoid prime, P prime, Q prime, R prime, and S prime. Go ahead and take a moment to do that now. Alright guys, so hopefully you realize that the rule here, it's a little tougher to see, but you are translating every point to the right 1.5, and you're going up 2. So your rule could be written out like this, that you're translating 1.5 to the right and 2 units up, or you can describe it in terms of x and y. So what are you doing to every x? Well, you're moving to the right 1.5, so you're adding a positive 1.5. And with y, you're moving up 2, so you're adding a positive 2. So this would kind of describe the relationship in the rule for this. Alright guys, that's all I've got for you today. I appreciate you listening. If you have any questions on this, please feel free to ask. You can also rewind and watch any part of this again for more clarification. Okay, now this is kind of a short, quick little video today, quick concept. So if there's any more examples of clarification you need, you just let me know. Once again, as I said at the beginning, I hope you're all doing well. I miss you guys, care about you. Let me know if there's anything you guys need, or if you just want to talk. I'll have a Google Meetup today between 9:30 and 11 a.m. Okay. With that said, hope you guys have. Let's think about this. Let's do marvelous. Hope you guys have a marvelous rest of your day. and I'll see you next time.